Hello everyone. Today we are going to learn about fundamental GIS concepts and map layout design principles. Understanding these concepts and principles are crucial for the people who want to improve their GIS skills and work in industry as special analyst or GIS analyst. In this lecture, we will learn about map projection, why it is important, how we use it in GIS, and what is the commonly used map projection in Australia and Sydney. We will see how height datums are important for measuring elevation. We will have a closer look at a scale bar, north arrow, and legend as the most important elements of designing a map layout. We will also talk about georeferencing of aerial images and historical maps. So, the learning objectives of this session are to become familiar with the concepts of projection systems and height datums and their effects on visualization in a GIS environment, to learn more about map layout elements and the necessity of including them in GIS maps, to become familiar with the concept of georeferencing and its applications. Now, let's start with map projection. As all we know, Earth is a globe, right? But we need to flatten the globe on a plane to make a map. The question is that how does the projection work? Flattening the Earth on a map is called projection. Have a look at this slide. When we want to project all the points of this surface on the plane, we see distortion for the points of the surface that are farther to the plane. And there is no distortion for the part that is in immediate physical contact with the plane. So what is the effect of this distortion? Please see the face of this gentleman on a globe and compare it with his projected face on different projection systems. This kind of distortion happens for the real-world locations and their corresponding points on a map. What is the solution to avoid these kinds of distortion? The solution is to consider tangent local planes on the Earth for each country so that we minimize the distortion. There are various types of projection systems. There are azimuthal, conical, and cylindrical methods of projection. In azimuthal method, a piece of paper is laid flat, touching a globe at a point. This type of projection is usually used for the poles. Another method of projection is conical, in which a paper is rolled into a cone shape and touches a globe on a circular line. Usually the tip of the cone is positioned above a pole. Cylindrical projection is another type of projection systems in which a paper is rolled into a cylinder around the globe and touches the Earth on a circular line, usually at the equator. What is projection system of Australia? It is known as Map Grid of Australia and is part of Universal Transverse Mercator or UTM. In UTM projection system, the Earth is divided into 60 zones. Each zone has a width of 6 degrees of longitude. A central meridian is in the middle of each longitudinal zone. Therefore, nothing is more than 3 degrees from the central meridian in each zone. Also, locations, shapes, sizes, and directions between all features are very accurate. How to set the map projection in QGIS? From setting in the main menu, you need to select options and then you will set the projection system to be Map Grid of Australia. Sydney is in zone 56. It is very important to set the right zone for each city. You can see GDA in this slide. What is GDA? We will learn about GDA shortly. Height datum is important when you work with elevation data. For years, there has been a question that how elevation should be measured. Where is the baseline? Where is the base surface to measure elevation? Let's call the base surface or the baseline as reference surface from now on. Many years ago, sea level was used as a reference surface for measuring the elevation and altitude. Studies showed that there are problems with using sea level as the reference for measuring elevation. Can you guess some of these problems? Let's help you. Do you think that sea level is always consistent throughout a year across all the areas in the world? If no, what could affect it? Indeed, winds, ocean currents, river discharges, and variations in gravity and temperature prevent sea level from being consistent in time and on all locations. Therefore, we need a more consistent reference surface for measuring elevation, right? Now, we can understand the concept of vertical datum. A vertical datum is a reference surface from which we measure elevation and altitude. I am not going to talk about the details of how a vertical datum is defined or measured. All we need from this concept for this course is to remember that the vertical datum of Australia is geocentric datum of Australia, and there are two versions of that. GDA 1994 and GDA 2020. Nowadays, GDA 2020 is used for many GIS works across Australia. Now let's talk about map layout. Do you remember that you made layouts last week in the tutorial? You added items such as legend, scale bar, north arrow to your map. And all these items are known as the map layout design elements of a map. Now we are going to learn more about these items or elements. There are different types of legends. You may have legends like the ones you created for your shapefiles last week that included symbols and labels for the symbols. You also may have a continuous legend for an image like the one demonstrated in the bottom right hand side of this slide that includes various ranges of elevation differences values. A legend consists of symbols, colors, and labels, and from the legend we can better understand the meaning of symbols, colors used in the map. A north arrow maintains a connection to a map frame and indicates the orientation of the map inside the frame. When the map rotates, the north arrow element rotates with it. Map scale refers to the relationship or ratio between distance on a map and the corresponding distance on the ground. Always be careful that the larger the denominator, the smaller the scale. Another element of a map layout is map title, and we need to add to our maps. Please be careful. To make a professional map, we always need to add title, scale bar, north arrow, and legend to the map layout. Now, let's talk about another important concept in GIS, which is georeferencing. A raster is a kind of photo that consists of pixels, and for each pixel we have a value. If we want to use these rasters for mapping, sometimes they are not in right location on the real world coordinates. Therefore, we need to georeference them. Georeferencing is the process of assigning real world coordinates to each pixel of a raster. Why georeferencing is important? Because sometimes we want to make historical maps in GIS to be able to digitize or analyze them. We might want to digitize aerial images with no spatial reference. We will learn about georeferencing in our tutorials in this course. Okay, in lecture 2, we learned about basic concepts of GIS such as map projection and georeferencing. We also learned about map layout elements such as north arrow and the scale bar. This is the end of lecture 2. Thanks for watching.